In this section, I want to cover sections 1.6 and 1.7. And for 1.6, let me start out with the following fairly simple but multiple step example. So we're going to do 2,365 times 982. And this is also going to provide us with a review on how to do this multiplication, how to carry, and all that other kind of stuff. So let's see here. The way you normally do this is I start with the 2 on the second line, and I take the 2 times 5 and I get 10. So I write a 0 below and I put a 1 up here, the carryover. And then I move on. Next I do 2 times 6, I get 12, but then I add the 1 for a 13 and carry another 1. Continue. 2 times 3 is 6, add 1 gives me a 7. And then finally 2 times 2 is 4. And now you're ready to move on to the 8 in the second line. So I'll put a 0 to start because 8, the place value of 8 is actually tens, and so you're technically multiplying everything by 80 when you do this line. So let's start. 8 times 5 is 40, so I'll put a 0 there, and I'll keep stacking these numbers up there. So I have a 4 that I carried over. Then 8 times 6 is 48, plus the 4 is 52. I'll carry a 5. And then 8 times 3 is 24, plus 5 is 29. I'll carry a 2. 2 times 2 is 4, plus 2 more is 6. And then for my last line, the line that begins with the 9, I'm going to start with 3 zeros. Made a mistake, 2 zeros, because you're multiplying by hundreds. That's why you have 2 zeros. And so I'll start. 9 times 5 is 45. I'll carry the 4, but I notice there's a 4 already up there, so I'll just leave it there. 9 times 6 is 54, plus 4 more is 58. Oh, look, there's a 5 there also. Okay, so 9 times 3 is 27, plus 5 is 32. And then finally, 9 times 2 is 18, plus 3 more is 21. And then what we do next is we add up all of these columns. So there's a big plus sign over here, if you will. The column of zeros, well, that's easy. 3 plus 0 plus 0, that's easy. And then now I have 7 plus 2, that'll be 9, plus 5 more is 14. Carry a 1. And then I have 1 plus 4 is 5, plus 9 is 14, plus 8 is 22. Carry the 2. 2 plus 6 is 8, plus 2 more is 10. I got a 0 there. Carry the 1. 1 plus 1 is 2. 2. I just bring down that last 2. So let me check my numbers. Something seems wrong about what I should be getting here. 430, I need to check right here. I think I have a problem with 2 zeros. So if you make a mistake, you can obviously check yourself with a calculator. But let's go ahead and see what did I do wrong on those numbers. So when I did 1 plus 4 was 5, plus 9 is 14, plus 8 is 22. That's good. 6 plus 2 plus 2, 4, and 6 is 10. So there's a 0 there. So that does not check. So let me go through my multiplications again. I'll start back with the 8 times 5. I got a 40. Remember, I put a 0 there and a 4 up there. 8 times 6 was 48, plus 4 more was 52, so I got the 2, put my 5. 8 times 3 is 24, plus 5 is 29, and I carried a 2. You see it there? 8 times 2 is 16, plus 2 more is 18. So it looks like my error was right there. There's an 8 there. And then there is a that 1 was still there. I probably will be. Let's take a look. So I have there's an 18. Let me go ahead and do my addings again. 0, then I have a 3, 7, 2, and 5 is 14. I have a 1, 5, 14, 22. That 2 is okay. I bring this 2 up here. 2 times 8 is 10. Plus 2 more. So that spot right there should be a 2. Carry a 1. And there's a 3. So there you go. I know I'm supposed to be the instructor teaching you how to do it, but also this was not a bad lesson on learning how to try to find your mistake if you make one. All right. So you're expected to know how to do that kind of stuff. All the carryover and all that kind of thing shouldn't be a big deal. What we're going to do is develop the rules for multiplying positives and negatives and things of that nature. So let me move on to the following. Take a look at 2 times 5. Now you were taught in school that multiplication was a fast way of adding. So this is the same thing as 5 plus 5. You write 5 down twice and you add it. And we end up with 10. So in the same fashion, if I were to do 2 times negative 5, that's the same as doing negative 5 plus negative 5. See, there's 2 negative 5s. And now because of the stuff that we already did, we know that when we add 2 negatives together, we're guaranteed to get a more negative number. And then I can just add the 5 and 5 and get a 10. So there it tells us that a positive times a negative equals a negative. And if I were to switch things, say if I were to do negative 5 times 2, you should know that you get exactly the same thing because when you multiply, the order doesn't matter. That's the commutative property that is responsible for that. So even if I had a negative times a positive, it's still going to be negative. So those are pretty simple ones. Most people remember those without much problem. There's some examples to illustrate this. If I do 4 times negative 8, knowing that my answer is going to be negative, all I have to do is concentrate on doing 4 times 8, and you should know that that is 32. As another example, once again, you know this is a negative number since it's a negative times a positive, and 11 times 11 is 121. Next, let's do negative 56 times 39. Now, this is not one that I can do off the top of my head, but I know it's going to be negative since it's a negative times a positive. And like anything else, all that I have to do is 56 times 39. Whatever answer I get here, I'll put after the minus sign. So I'll do it just like the previous one. I'll try to do it correct this time. 9 times 6 is 54. 9 times 5 is 45 plus 5 more is 50. Bring a 0 down. 3 times 6 is 18, carry a 1. 3 times 5 is 15, plus 1 is 16. And then add up my columns. So my answer is negative 2184. Next property is not one that I'm going to be doing a whole lot with right at the moment, but it's useful for developing what we're going to do next. Look at what I have here. I have 2 times 7. We know that that's equal to 14. But let me do it slightly differently. Now, it's true that 3 plus 4 is equal to 7. And you should normally do the parentheses before you would multiply. However, for this one time, I'm going to break the parentheses out and do this kind of business. By that, I mean I'm going to do 2 times 3 plus 2 times 4. Let's see what we get. Now, the order of operations tells me we should do the multiplication first, so I would get 6 plus 8, which is the same answer. The rule, the property itself, looks like this. If I have a number and I have a sum like that inside of parentheses, the rule says that I could take A times B plus A times C. That is the distributive property. Right there. And it works for subtraction as well. So if I want to do 5 times 12 plus 8, you could add the 12 and 8 first, but the distributive property says that you can do this. 5 times 12 plus 5 times 8. And so you'll end up with 60 plus 40 will end up being 100. Similarly, 3 times 9 minus 2 will equal 3 times 9 minus 3 times 2. So whatever symbol is in here, plus or minus, goes into that spot as well. So we end up with 27 minus 6, and that equals 21. Now let's move on. I don't know if I want to call this an example or not, but I think what I'm going to do is the following. I'm going to do negative 5 times negative 6 plus negative 5 times 6. There's a multiplication in here. I don't know if I've been indicating that or not, but anytime you see a number right up next to a parenthesis, it is multiplication. Now, on the other side, I'm going to do this. So I have the distributive property is what I'm doing here. So when you look here, negative 5 times negative 6, that'll be this part right here. And then negative 5 times 6 will be this part right here. Now, what I'm going to do is I'm going to do the left side and the right side. So what we have on the left side, the negative 5 times the negative 6, I'm going to wait on that for a minute. But I do know that negative 5 times positive 6 is negative 30. On the right side, I'm going to do the parentheses first. Negative 6 plus 6 is 0. And we know that anything times 0 is equal to 0. So we have negative 5 times negative 6 plus negative 30 equals 0. However, we also know that 30 plus negative 30 equals 0. What does this tell me? If you look at these two things right here, everything is the same. So we have a 0 here, a 0 here. I have a negative 30 here, a negative 30 here. But for this last piece, I have negative 5 times negative 6, positive 30. This leads me to believe that negative 5 times negative 6 equals positive 30. So what is this rule telling us then? If I have a negative and I multiply it to another negative, I get a positive. So those are your rules of multiplication. We have negative times positive equals negative. Positive times negative equals negative. negative times negative equals negative. And I guess I don't need to put this one, but I will. If you take a positive times a positive, well, that equals a positive. So those are the rules for multiplication involving positives and negatives. Just a couple of examples to illustrate what we have. Negative 7 times negative 11. That's going to be a positive answer since you're multiplying two negatives. So all I have to concentrate on is 7 times 7, which is 77. Negative 31 times negative 95. Once again, I know it's going to be a positive answer. So in order to do this, I am not going to be able to do it off the top of my head, so I will break it down as such. Let's start. 5 times 1 is 5. Then 5 times 3 is 15. Bring down a 0. 9 times 1 is 9. 9 times 3 is 27. And then let me add everything up. Carry a 1. 9. So it looks like 2,945. Let's do 3 times negative 5 times negative 2. Now, according to the order of operations, when you have back-to-back things that are of the same order, you go from left to right. So since I'm doing multiplication here and here, that means I'm going to go from left to right. So I'm going to do 3 times negative 5 first and get negative 15. And then a negative times a negative is positive. I end up with positive 30. Sometimes your book uses the X for multiplication. I don't like it because at some point in this class we will be using the letter X for things, but for the time being, whenever you see an X, you can think of it as multiplication. The only reason I'm using it is because the book sometimes does. As before, you're going and doing multiplication and multiplication over and over and over again, so we'll go from left to right. So I'll start right there. Negative 8 times 3 is negative 24. And notice that I write down the steps. I bring down everything else. I only do one thing at a time. So for my next step, I'm going to do negative 24 times negative 1. That's positive 24. And then finally, I know that I'm going to get a negative answer, so I'll put a negative. 24 times 3, you can do it off to the side, but I happen to know that one is 72. Now we'll do some more stuff, but for the time being, I just wanted to get multiplication out of the way. Once we get division here, then I'll be able to do some combinations of things. So we'll go into 1.7. This is division of integers. So let's take a look. What happens if I take a positive and divide it by a negative? Well, you probably know that this answer is going to be either 12 or negative 12, depending on that. But if I say it's negative 12, remember how to reverse a division problem. Is it true that 24 equals negative 2 times negative 12? That does. We now know that the product of two negative numbers is positive. That checks out, so that means that this is the answer. So we have a positive divided by a negative equals a negative. It's going to follow the exact same rules that happened for multiplication. So if I did negative 24 divided by positive 2, you would be right in expecting it to be negative 12. That's because if you reverse this and wrote negative 24, that does equal 2 times negative 12. So we have a negative divided by a positive equals a negative. Now, I don't write out positive divided by positive because you've been doing that your whole life. However, one thing we haven't done yet is like negative 24 divided by negative 2. Well, as with multiplication, you know a positive or a negative times a negative is positive. So you probably expect that a negative divided by a negative is also positive. In fact, you may have guessed that this is 12, and that is correct. Because if you take negative 24, that in fact is equal to negative 2 times 12. So a negative divided by a negative is equal to a positive. So when I do something like negative 32 divided by negative 8, you know that the answer is going to be positive, and then so all you have to concentrate on is what is 32 divided by 8? That's positive 4. Another way of writing a division is like this. If I write 45 divided by negative 5, that's the same thing as the previous problem. It's the same type of problem. It's just a different way of writing division. You have a positive divided by a negative, so you immediately know that your answer is negative. And then you do 45 divided by 5, and that equals 9. Negative 12 divided by 12, you know it's negative, and then 12 over 12 is just 1. Now, division has some complications. One of them is with 0. If you have something like this, 0 divided by 5, you know that that's equal to 0, because if you reverse this and do 0, it does equal 5 times 0. However, if I try to reverse this, what do you think that it should be? Well, who knows what it's going to be. If I put any number over here, I don't even know what you'd try, but let's say I put a 0 over here. Well, when I reverse it, 5 would have to equal 0 times 0, and that's not true. 5 is not equal to 0. So this is not true. In fact, try it on your calculator. Type it in just like you see it, and you will get an error message on your calculator. So we simply write this as our answer whenever we put a 0 after the division sign. In fact, if you played this game and also tried to do it on your calculator, guess what? So no matter what, if you try to divide by 0, you're going to get something that is undefined. So the way to remember this, I guess, is any number divided by 0 equals undefined. So just as one quick example, it may look like this. You'll get undefined as long as you're dividing by 0. Let's do a hardier example here. I have 43,176 divided by negative 21. So what I know right now is I know that I have a negative answer. To get the rest of the number, I'm going to have to take 21 and divide it into 43,176. So let's go through the steps, and part of this is to remind you how to work such problems. So as we work this thing, 21 goes into not 4, but it goes into 43 twice. So I'll put a 2 right above that 3. Where you place these numbers is extremely important. Now what you do is 2 times 21 is 42, and then subtract. 43 minus 42 gives you a 1. You are permitted to bring down the next number, so that gives me an 11. Unfortunately, 21 does not go into 11, so I have to put a 0 above the 1. 21 goes into 11 0 times. So bring down a 7 now. How many times does 21 go into 117? And I think you'll find that it goes in 5 times. 5 times 21 is 105. Then subtract. 117 minus 105 is going to be 12. I can bring down that 6. 21 goes into 126 exactly 6 times, because you get a remainder of 0. And so I now know my answer is negative 2056. So those are the rules, the basic rules for multiplication and division. Let's mix a few things up right now. And what I want to talk about in particular is this guy. Unfortunately, the way that it is written, it makes you think that multiplication comes before division and that addition comes before subtraction. So right here, these two things are actually equal to each other. I'll put a little equal sign in there. And these two things are equal to each other in terms of what you would do first and what you would do second and so on. So let me do an example real quick to illustrate what I'm talking about here. Suppose I wanted to do 144 divided by 2 times 3. Now, if you think about Pemdas and you listen to just Pemdas, you would probably try to do the 2 times 3 first, but that is incorrect. So if you were to write 144 divided by 6, let me see if I got a pen big enough to make this happen. There we go. That is wrong. I don't know. Let me go back to my pen. What you have to do is this. 144 divided by 2 times 3. What you have is you have division followed by multiplication. That means division and multiplication occur back to back. The way you approach these is you go from left to right. Because division and multiplication are equal. So I'm only going to do this portion first. 144 divided by 2 is 72. 72 times 3 is 216. So when you see multiplication followed by division, you would do multiplication first. But if you see division first, that's what you would do first. So Pemdas, the way it's written, is a little bit misleading, especially if you're trying to just remember what the letters stand for and you don't remember anything else. Instead, what I typically write for my students is this. So I put the D and the M over top of each other, and I put the A and the S over top of each other. So that if I were to see 144 minus 2 plus 3, I wouldn't do 2 plus 3 first. I would do the subtraction first. And get 142 plus 3 would equal 145. Obviously, if I switched the addition and the subtraction, this would be different. So if I did this, 144 plus 3 minus 2, well, now I would do addition first, and I would get 147 minus 2, and I'll end up with 145 also. So that's not guaranteed to happen. That just happens in this particular example. So maybe it was a bad. Actually, you know what? This is a really bad example to use. So I'll erase it, and let me do this one instead. 144 plus 2 minus 3. So now I have the addition first. I'll go here, 146 minus 3, and that'll equal 143. Let's do some more extended problems. Since all I have here is multiplication and division, I am going to just go from left to right. So I'm going to start right over here with those two. Positive times a negative is negative. I get negative 140, and I will bring down the entire rest of the problem. Once again, I will just do one thing. I will do this part here. Negative divided by a negative is positive, and I happen to know that 140 divided by 7 is 20. And going from top to bottom, you can see that as I progress, the amount of stuff that I have to do yet is getting smaller and smaller until I get down to just one last step. Now 20 times negative 4 I know is negative. 4 times 20 is 80. And I know that a negative divided by a negative is positive. So for a problem like this, now parentheses should always be done first. So when I'm doing this, I'll see that I'll get a negative 60 before the division sign. After the division sign, I will get a 15. Now I know my answer is going to be negative since I have a negative divided by a positive. So it's going to be negative 60 divided by 15 is 4. Let's try 150 divided by the absolute value of negative 15 times negative 1. Well, the absolute value is kind of like parentheses, so you would do it first. Now, the parentheses around the negative 1, they don't count as parentheses as it is because there's nothing to do inside of them. The only reason why the parentheses are around the negative 1 is so that you don't have something that looks like this. That is never written in a math book. It's just an agreement among mathematicians not to do that. So we put parentheses around the negative. So don't write that, but don't confuse it with parentheses either. I am going to go from left to right. That means I'm going to do this part first. 150 divided by 15 is 10. And then finally, 10 times negative 1 is negative 10. For this one, negative divided by a negative I know is going to be positive. So in order to do this problem, I have to do this. And I've picked this to be a little more of a complicated problem than the rest of them. Let me show you something that I'm going to do. I'm not going to use what I just wrote because I don't like the spacing. So let me show you how I actually do write it. I'll put my 186 out here. There's no problem with that part. But now let me write the 2, 3, 0, 0, 8, 2 with lots of spaces so that I don't confuse where I need to put the place values. It'll be easy for me to put them in the correct spots and not miss what columns they're supposed to be in. So let's start. The 186 is not going to go into 2, it's not going to go into 23, but it will go into 230 one time. Now 1 times the 186, and then let me subtract that line. So in order to do that, I'm going to have to borrow. 10 minus 6 is 4, and then I have 2 minus 8. I can't do that unless I borrow again. 12 minus 8 is 4. And now I'll bring down a 0. You're allowed to do that one time. Now I can see that if I do 3 times 186, I'm going to get like 372, or 2 of them times 186 would be like 372. But 3 times 186 is over 500. So I know to do just a 2 right here. So like I said, 2 times 186 is 372. And then I subtract again. I have to borrow again. 10 minus 2 is an 8. 3 minus 7 I can't do, so I borrow again. 13 minus 7 is 6. I can bring an 8 down. 688. 186, I think, let me do a trial multiplication here. I think 5, if I do 5 times 18 is 90. 6 times 18, maybe 3. Let's try 3 and see what happens. I get 558. If I do 4, that'll be too much. So this, we have a 3 here. Let's subtract. And then bring down the 2. I'm sort of losing my columns as I was speaking. 1302. Let's see, how many times would it do that? Probably 7. I'm going to try 7 times. So I have a 2 there. Well, that's nice. 6 times 2 is 42. I'll put a 4 up there. 7 times 8 is 56. Plus 4 is 60. Carry the 6. 7 times 1 is 7. Plus 6 more is 13. Oh, beautiful. 1302. 1302. Subtract, and it works out. So what would I... So my answer is 1,237. My last example will be something of a word problem. We're going to try to get you comfortable with these things by starting with easy ones. So let's start this off with the distance from Bangor, Maine to Los Angeles California is approximately 3,200 miles. Suppose you were going to drive from Bangor to Los Angeles. So if you drive from Bangor to LA at 50 miles per hour, how long does the drive take? So in order to get that, you probably know this equation. Distance equals rate times time. But if I want to know how long something is, you probably also know that time equals distance divided by the rate. So in this particular problem, I do want to know how much time this is. The distance is 3,200 miles and the rate is 50 miles per hour. So I know in order to do this problem, I have to do 50 into 3,200. Well, 50 doesn't go into 32, but it does go into 326 times. And then I'll subtract and bring down to 0. 50 goes into 200 exactly 4 times. So the answer to this problem then is 64 hours. Now, if the same trip were done in a plane flying 400 miles per hour, then how long would it take? So the same thing, t is the distance divided by the rate, and this one is a lot easier to do. If you try to do this off to the side, it won't take long before you'll see that 400 goes into 3,200 exactly 8 times. So if you took the plane, it reduces the time by quite a bit to 8 hours.